Hello, class. So we are going to finish section 4.3 in this recorded lecture, and it really ends with a business application modeling using the quadratic function. And the next section, we're going to continue modeling using the quadratic function in section 4.4. So what I decided to do here is just walk through another big example. And this one is, if you had the textbook or if you looked on the ebook, it'd be problem 89. And this one states, now the monthly revenue R with selling wristwatches is defined by the equation 75x minus 0.2 x squared. And the monthly cost is defined by 32x plus 1750. And so let me just go to the whiteboard and write these up here. So the R of x, 75x minus 0.2 x squared. And to be honest with you, that's not a great revenue function because you have this negative aspect of a second order effect of the wristwatches. And the cost function is usually linear. And we discussed this in the last section, but it's really important that the cost function is split up into two, where the 1750 is what we call fixed cost. And those are costs like insurance, rent, paying your accountant, a variety of different other types of costs that does not affect the manufacturing of the wristwatch. And the 32 is what we call variable cost. So every time that you make a wristwatch, it costs you $32. And so the more wristwatches that you make, the less the percentage of the fixed cost will affect the total cost of your business. So that ends up being a really important attribute. And in my life, I modeled my cost function and knew exactly what my fixed and variable costs were. And so that answers question one. Question two asks the question, what is the maximum number of wristwatches I am one bad speller, huh? Maximum revenue. So you want to find both, actually. The maximum X value, which is the number of wristwatches. So remember, X is the number of wristwatches. So how do we do that? Well, what kind of equation do we have? Well, the R is a quadratic. So let's write out, we have the A value is minus 0.2. The B value is 75. And what's the C value? C value here is 0. So what do we have? Our y-intercept is 0, which makes sense in a revenue equation because if you sell 0 of something, the wristwatch, you're not going to make any money. So that would be 0 revenue for 0 wristwatches. So the A value is negative. It opens down, right? So it would look like that. And so what is the maximum? Our favorite point, the vertex. So what we want to do is we want to calculate the vertex for the revenue function. And so the vertex would be minus b over 2a. And so we have minus b, which would be minus 75. And the a value is minus 0.2. So when you do that calculation, minus 75 over minus 0.4, you can see the two negatives will cancel. And you end up with 187.5. And it is kind of a real world calculation because you can't have half a wristwatch, right? So 187 or 188 would be the logical right answer because you can't have a half a wristwatch, right? But for the math reasons, we always will use the decimal aspect of it as well. So for the math part, I'm going to leave it at 187.5, knowing physically you can't have a half a wristwatch. Because the reason why I do that is I want to find the vertex or the y value of the vertex, which would give us the maximum revenue in dollars, right? So if you plug in 175 and a half, and you do this calculation, you just have to plug it in. All right, so see what I mean by plugging in? So here you definitely need a calculator. And I actually did this before. And so this number would be 7,031 and 25 cents. So that's the vertex right up there. And so need a little bit of space here. So I'm gonna erase this line here. And we'll put the vertex right up here. So it'll be 187.5 and then 7,031.25. So that answers question 2. And so question 3 states derive the profit function. So if we go up to the profit function, well, remember, profit is revenue minus cost. So what do we need to do with regard to this? Just do a little algebra. And so let me find a little room here. So there we go. So the profit equals R minus C, revenue minus cost. So this would be the revenue of 75x minus 0.2x squared, and you subtract the cost, which makes sense, right? Money coming in, money going out. And so you subtract the cost. And so 75x minus 0.2x squared, and then we have minus 32x minus 1750. And so we have just one x squared. We have combined the two linear terms. And so that would be plus 43x. And then we just have 1750. So there's our profit equation. And you look at our profit equation and you say, ooh, I got another quadratic. And so when we do this analysis and say, what is your maximum profit? Well, how many wristwatches do you need for your maximum profit? And then what would be your maximum profit? Again, same strategy, right? We have an A value minus 0.2, B value of 43. And the C value now is the fixed cost of minus 1750. So again, it's pointing down. A is less than 0. The parabola would look like that, and the vertex again is our maximum. So what is the x value of our vertex? So the x value of the vertex is minus b over 2a. And so now we'd have minus 43 over 2 times minus 0.2. Again, the negatives will both cancel out, which is good. And you would see that you would get 107.5 wristwatches. Again, physically, it doesn't make any sense, but for math-wise, that would be this point right there. So the question is, what is the maximum revenue? Well, plug in the x value of the vertex into your profit equation. Okay, what do we have here? Plus 43, 107.5, minus 17.5. I did that calculation already. Then you would see that it's a measly $561.20. And you do want to realize that your maximum revenue and your maximum profit would definitely be different because you're not taking into account any of the cost aspect when you're talking about revenue. And so that would be the maximum profit. So redid the board a little bit, so I paused the recording, but to move forward, the next question, and a really important question if you're a business owner, is what's your break-even point? And we talked about the definition of the break-even. So the definition of the break-even point is when your revenue equals your cost, or another way to think about it is when your profit equals 0, which is the exact same thing, right? The only way your profit's 0 is when the revenue equals the cost. And since we have the profit equation, I'm going to use that one. So we have 0.x squared plus 43x minus 1750, and that equals 0. So here's a perfect example where this is a not factorable. And so the only way to solve this is to use the quadratic formula. And so when we set it up, we have minus b. Oh, let me put these values down here. Be minus b, so it'd be minus 43, plus or minus b squared, which is 43 squared, minus 4, minus 0.2, minus 1750, all divided by 2 times minus 0.2. So remember I said the most important thing to do is calculate the b squared minus 4ac. And if it's positive, then you know you're going to have 2 solutions. So 43 squared is 1840, 43 times 4 enter. 1850. So it looks like what's underneath the square root would be the square root of 449. And you say to yourself, okay, I have positive, so you would walk through the rest of the calculation. And I'll leave that for you in your calculator to do. And I did it already. And you get 165 or 54.4. I'm sorry, 54.5. So to finish the analysis, it's very useful to take a look at the sketches or graphs of each one of these equations. really a pain to do by hand. So I would recommend using some sort of application to take a look at these. And we could take a look at the Desmos website, and I use that quite a bit to graph things. And so what I have done is pause the lecture and actually type everything in so you could see how everything looks and didn't have to listen to me type everything in. So these are the three equations that are graphed. The top one is our revenue equation, and it's in red. And you can see it's a quadratic, so it's a parabola. It points down. And you can see that at the 0, 0 is really the first physical point. It doesn't make any sense to sell negative wristwatches, right? And as you get to the vertex, which is somewhere up here, right? There it is. It would be the maximum. And so you can see it's 187.5 and then 737.25. So you could see after that, the revenue starts coming back down again. And what ends up happening is this minus 0.2x squared starts to take over the equation when x gets really big. And you could see at the other x-intercept of 375 watches, you would make 0 revenue. And it's interesting that this point doesn't correspond to the exactly to the maximum profit, because again, it's dependent on the cost as well. And you can see here's the cost function, which is the blue line, and you would expect that to be a nice linear equation, and yes, it is. And you can see that our y-intercept is 1,750, and that's our fixed cost. So if you make 0 wristwatches, you still have to pay your rent and your insurance, et cetera, et cetera. So what's really interesting is where the two lines intersect here, you get our 2 break-even points. And so this would be our break-even point at 54.5 and then 160.5 as well. So those would be the 2 break-even points that we calculated. And then the green is our profit equation, which was this third equation typed in. And you could see that you make 0 profit where it hits the x-axis here. Let's see if I can find one. Yeah, looks like it's 160.5. And so that would be the break-even point. And then 54.5 would also be the other break-even point. So again, break-even point is where the revenue or cost intersect, or also where the profit equals 0. And so our maximum profit is the vertex over here, and it looks like it's 107.5. So that's how many wristwatches, and you only make $500, $561.25 selling that much. So you can see how the graphs correspond to all the calculations that we did as well. And so this ends the first example, real world application. Business was modeling using quadratic functions. And this ends the recorded lectures for 4.3. In section 4.4, we're going to do more quadratic modeling and applications.